Hi, my name is Bahadur Akhmedov. Welcome to the course of multivariable calculus. In this lecture, we're going to introduce the series. Previously, we talked about the sequences, and we say that a sequence is just a list of numbers which are ordered in some way. And usually, we are given some general form to generate any number in the sequence. So if we've learned about the applications of this sequence, for example, we would be interested to make a tower in this way using, for example, a Lego brick. And the sequence is going to be the number of the bricks which were used in every row of this tower. For example, A1, it's going to be, hey, how many bricks we have used in the first row? It's going to be 1. A2, in this case, it's going to be 3. A3, it's going to be 5, and so on. And in general, an is going to be equal to 2n minus 1, right? So it's going to be an odd numbers, just a list of odd numbers. So we use this general formula an in order to find the number of bricks used in nth row. So now, what if I want to know how many bricks I'm going to use until that nth row, or including the nth row, in total? For example, hey, how many bricks we need to use in order to in the first two rows? It's going to be the sum of A1 plus A2, and I'm going to denote this as the sum of S2. So it's going to be 1 plus 3 in this case. So if I would like to know, hey, what's going to be the sum of the number of the bricks in total which we used in the first three rows, it's going to be S3. It's going to be A1 plus A2 plus A3, which is equal to the 8. So in general, the sum of a sequence is going to be called as a series. So if you have a sequence, A1, A2, and so on, AN, and so on, until, so it usually goes to infinity. The sum of the sequence is going to be called as a series. So the sum is called as a series. And usually it goes to infinity. So this is the definition of the series. In this lecture, we are going to introduce the concepts of the convergent and divergent series. So previously we talked about the convergent and divergent sequences, right? So where the nth term is going to converge to some number, to some finite value as n goes to infinity. So in this case, we are going to learn whether the sum of a series is going to converge to some number or not. So one of the famous examples of a series can be written as a pi, number pi. So pi can be written as 3.1415 and so on. And actually you can write down the numbers until forever. So you can write infinitely many numbers after the digits. So at the same time you can write down this pi in this way. So let me write this. So 3 plus 1 divided to the 10 plus 4 divided to the 10 in the power of 2, 10 squared, plus 1 divided to the 10 cubed, plus 5 divided to the 10 in the power of 4, plus 9 divided to the 10 in the power of 5, plus 2 divided to the 10 in the power of 6, plus 6 divided to the 10 in the power of 7, and so on. So it appears we can write down a pi, so the number pi, as an infinite series. So we can write the pi as an infinite series, right? So and actually, as much as terms we take, for example, if you take these 3 terms, you're going to get 3.14. If you get like 10 terms, you're going to get more closely value to the pi. And if you take the infinite sum, you are going to get the exact value of the pi. So what I wanted to know is whether if you write down the series, you can get a sum to converge to some number. So in this case, this series is going to converge to the number pi. So So let us define the series one more time. So we defined the series as a sum of a sequence, A1, A2, A3, and so on. And in general, it would be better for us to figure out some more compact form. And we are going to do this using so-called sigma notation. So this is going to be the sigma of an. N goes from 1 to the infinity. So this is the definition of a series. So sometimes the series is going to converge to some number and sometimes not. So let us consider a couple of examples. Example of a series. So let's say I've got a series which is going to be just the sum of numbers. So like natural numbers, 1 plus 2 plus 3 plus 4 plus 5 and so on, plus n and so on. So in general, the general term is going to be written as n, and you can write down a series as the sum of n when n goes from 1 to the infinity. So obviously we know that the sum of this series is going to be equal to infinity, right? So in order to prove or show this mathematically, what we're going to do is we are going to define so-called concept, which is going to be called like so-called concept of the partial sum. So what I wanted to do is I would like to denote the sum of the first n terms as the partial sum. Partial sum. And the infinite series, which is going to be the sum of the terms on top, infinitely many terms, it is going to be the sum, it is going to be the limit of the partial sum when n goes to the infinity. So these two concepts are equivalent. So basically, finding the sum of infinitely many terms mean to find the limit of the partial sum when n goes to the infinity. So we know how to find the partial sum for this series, right? So the sum of the natural numbers from 1 to the n is equal to n times n plus 1 over 2. And there is an interesting story behind this, related with the Gauss. So the German mathematician, the famous German mathematician, he derived the formula of the sum of the numbers from 1 to the n when he was at school. So he used this technique. Let me show you for the small number of the numbers. Like say I've got a sequence or a series, sorry. So the sum from 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, let's say. So in this case, it's going to be sum from 1 to the n, right? So he noticed that if you take the numbers, the first one and the last one, the sum is going to give the 8. He also mentioned that if he adds the 2, like the second number, and the pre-last number, he also gets 8. If he adds these two numbers, he also gets 8. So what he can do is he can just so if n is equal to the 7, he can write down say the first and the last one is always going to give you n plus 1, right? And there are n over 2 this kind of terms, n over 2 n plus 1s, right? Because he's splitting the sequence into the two parts. So this is basically just simple derivation of this formula. So the sum of the numbers from 1 to the n can be found by just multiplying n to the n plus 1 and divided this to the 2. So what we need to do is we would like to know whether this series is going to converge to something or not. In order to do this, so the sum of the numbers like n goes from 1 to the infinity, it is going to be equal to the limit of the partial sum when n goes to the infinity. So we know that the partial sum of the numbers from 1 to the n, it is going to be equal to the n times n plus 1 over 2. When n goes to the infinity, this is going to go to infinity, right? So it means that this sequence is not going to converge to anything, right? So this kind of series is going to be called as divergent. So this series diverges. So let's consider another example of a series which is going to converge. So example. So let's say I'm going to add the numbers 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus and so on. So you see that I'm just adding the powers of the 1 over 2. So you can write down this series in a more compact form by writing down this sigma notation, like summation of 1 over 2 in the power of n, when n goes from 1 to the infinity. So you can try to find out the sums, like the partial sums, and see the values, but you can see you will see that these values are going to converge to 1 actually. So we can try to find the couple of values of the partial sums if you want. So if so let's start with the partial sums. Partial sum S1 is going to be simply A1, which is equal to the 0.5, right, in this case. S2 is going to be the partial sum until 2. It's going to be A1 plus A2, which is going to be 0.75. So S3, which is going to be the partial sum of the first 3 terms of the series, is going to be 0.875. So we're going to go until, for example, 25th term. It's going to be the sum of A1 plus A2 until A25, which is going to be 0.999999997. So which is really close to 1. So in our next lectures, we are going to talk about more like a general terms of the convergent infinite series and how to find this limit. So this kind of series, in this case, so this series is going to be called as converging series. So this series converges. So again, in this lecture we defined the series. So previously we defined a sequence as the list of numbers, which usually goes until infinity. In this lecture we say that the sum is going to be called as the series, and we are going to denote this as an, and goes from 1 to infinity. So this is called a series. And a series can converge to some number or can diverge. Basically, the sum goes until infinity, or it never goes to some number. So in this case, it is going to be denoted as finding the limit of the partial sum when n goes to infinity. So in our next lectures, we're going to talk about the power series. We're going to talk about the geometric series, and so on.